Interesting. The only countries that truly do this dual system, working with industry and going to school, are Germany, Austria.
German speaking, I think Germany and Austria.
Right. And you said that looks like the Chinese are...
I think the Chinese will copy the system.
Right.
I know a friend of mine was at the end of his university, he went to China to tell them, to show them how to do such a training.
Right. And I met another teacher in Belgium, and he said the Chinese were also over there.
Yes.
And asking a lot of questions because they wanted to incorporate this Northern European vocational system. When I was over in the Chinese vocational schools, I found that their vocational schools were mostly theoretical, but I didn't see the practical there.
Yes, but I know some companies or in some regions, I think they try to copy our system, to use our system.
Yes.
But our system is expensive.
It is expensive.
It is expensive.
It costs a lot of money, but it has a great outcome too.
Yes, and in Germany, we can only be competitive if we do good work, high-tech work, and therefore we need a high-class or high-educated workforce.
Yes, I agree.
Yes.
Here we're standing in front of another CNC machine you have, but this is a very modern machine, is that right?
It's a very modern machine, about 2 years old.
So this is something you would definitely see in industry right now.
You would see it in industry for small parts.
And then what does this machine do?
Okay, now they're testing a program of this part. I cannot see a technical drawing.
Oh, this is the part right here.
This is a part
being made.
Moment. This is a part being made.
Right.
There it holds and it turns around.
Okay, and a part like this, it might go into what type of operation? What way do you use it? Give me an example of a part. What could it be used for?
This part is just for rehearsal. I don't think it's a real part that would be used in a company. It's a very simple part.
But
maybe you would, if you put a thread on it,
right,
you can use it as a palm grip.
But airplane parts could be made in here.
Airplane parts,
auto parts. So now we're in a classroom where their kids are learning what? How to program a CNC machine.
A CNC machine.
And basically a CNC machine mills things and makes parts, right?
It makes parts, complicated parts.
Very complicated parts.
Very complicated parts.
And what's going on right now? It's actually milling a part, right? You can see it's drilling.
Like this.
Oh, there you go.
After 10 years of use, it will look
like that.
This. Yeah.
Okay. So these are just basic simulations, easy things to do right now.
This is a little bit complicated.
Oh, is it? And these were all programmed in the machine, right?
You can program it in a machine, but we can program it on the computer.
On computer too.
And with a diskette, we can transfer it to the machine.
Oh, okay, I got you.
Every student can program, and if he thinks his program is okay, he does a simulation.
Right.
Then he can go to the machine.
But basically, this is modern industry. This is how everything's built now.
Yes.
Through CNCs.
Yes.
Yeah. Into this room, and these machines look pretty old, maybe 20, 30 years old.
Yes.
Why are you still using these machines at this school?
Because, as I told you before, you have to know what you're doing, and you can see it hands-on.
Right.
Really hands-on, you have to do it by own hands.
Right.
Not by computerized machines, really by own. You have to understand how a machine works.
Right.
And as this machines, they are simple, you can understand it very easy, you can explain very easy, and if you know the easy parts, you can go to the more complicated models.
Right. I understand. So you don't plan on in your school to throw these out. You want to keep this.
We need this. It's very important.
Right.
If you can do your task on a simple machine, you will be able to do it on a CNC.
You can see it much better.
Yes, and vice versa. If you can program, you cannot go to this.
So what's this student doing here right now? He looks like he's working with some optical sensors.
They are working with the cylinders. The cylinders have to do special movements.
Right.
I don't know exactly what, but they have to choose what sensors they use. They know if this cylinder is in this position, You need a sensor that recognizes
I
it.
see what you're saying.
And they have to think, do I use an optical sensor, inductive, or the capacitance?
Right.
And they said, it's a reflective material, therefore I can use this optical sensor. If it was not reflecting metal, they would use an inductive.
And
if it was no metal, if it was plastic, they would have to use a capacitance sensor.
But it still looks like they're working out things by hand.
By hand.
Right.
First, do a sketch by hand.
Right.
Think how to do the task, and then set it up.
So again, I'm going back to the US system, starting with kids that are basically 12 years old.
Yes.
You think every kid should be learning on a computer all day long?
They should have access to a computer, but they should use a computer if needed.
Right.
A computer is an assistant, I think.
Right, but it shouldn't be 100% of your work is done on a computer.
I don't think this is not a good idea.
Right, right.